Guys, and welcome to another episode in my machine learning series. And in this series episode, I'm going to be demonstrating LSTM. In my previous episode, I had talked about the time series generators, and now we're going to use the time series generators to produce data for the LSTM. So before we start, I wanted to put a reference here from where I have gained some understanding of how LSTM parameters work. So that link is up here, and one of the diagrams I like to refer often is this diagram, which kind of makes you understand that what the hidden structure of the LSTM would look like. It's a bit confusing in the beginning, but an LSTM cell has multiple gates, forget gates, input gates and output gates, and then each gate kind of behaves like an artificial neural network that you may already be familiar with. So this understanding that you have the usual weights and biases, and that's what makes up each of these gates. Once you understand that, then it kind of breaks down the whole LSTM as just a bunch of a combination of ANNs, and then you can understand that what the hidden states are doing. So I would highly recommend you go here before you go look at my video. Please do visit this blog to gain a clear understanding of how the LSTM is really um, implemented kind of like an ANN inside. With that said, I want to also talk briefly about the fact that the LSTM is a long short-term memory. It's an evolution of the recurrent neural network, RNN. And the thing that's interesting or new in LSTMs is that it has kind of solved the problem of vanishing gradient in which you can't remember too far back. So it has a little bit of a longer term memory built into it as well as the short term memory. Now, my purpose in this episode is to show you that you can use this method to kind of predict a time series. There's many other uses of this, but I'm going to be focused on time series and how it can help you predict time series and time series prediction based on the past data or history. And by using this kind of structure, you can you can predict a time series and also measure the error. And for me, it's mostly the error measurements that are important because I can predict when there are deviations from existing behaviors. And that's one of the use cases I was working with. So the important thing here is that we include a whole bunch of these libraries for plotting and TensorFlow, obviously, and NumPy are the big ones. Pandas is another one that we use all across. Um, and then once we are past the including all the stuff, then basically pull in our CSV file. So let me just run through this real quick with you. So we pull in our CSV file, and we're going to plot the CSV file just to see how the input file looked. And so there you go. That's what the input data was. Now we're going to try to split that data into train data and test it. And the test percent is 0.4. So if I run this, you will see that this is the training data in orange and the blue is the test data. We're going to run our test on that. Okay, so with that, now we are using our familiar generator, and I think I'm using TensorFlow 2.5. So we're going to use the time series generator, which I've described before. Now, I'm using the scale train and scale train both. And if you see my previous video, because I'm just using n samples of the input data and predict one sample of the output, I can do this. I just use the scale train, scale train. My length is 30, so I'm going to input 30 points and predict 1 point after that. My batch size is 1, so I'm just putting 30 and one output, and that's what I'll train on, one at a time. And then the whole um, set would be used in such a way. So the generator will create this data, and it creates 4,900 batches here. Okay, so over to, let me just run that. And so then we look at the model. So the model is created using feature of 1, because even though I have 30 time samples, the feature is only 1 because I have this one stat, right? This one stat is my only vector. So the way I create it is that I create a sequential model using keras, and then in the sequential model I add the LSTM layer, and I put 50 hidden uh, units inside this LSTM layer. Written sequences true for this first layer. Input shape is length comma features, and my length is time steps, which is 30 time steps, and my feature is only 1 because I'm only inputting 1. Now the next one, I've used cascaded layers, and then I converge it to 1. So I use another one, and this layer would basically just output to 1. And then I compile with a mean square error and Adam optimizer feedback, and that is my model. Now, it took me a while to understand why it takes so many parameters, but like I said earlier, if you go into this blog and see that there are 4 of these, and then each one of these has certain numbers. The other thing is that you can see that this is 30 time steps, but the important thing to understand is that this represents not 30 time steps, but just one time step. So if you follow that, you have 50 feeding back plus one of this. So using that, if you do the math here, then there's 50 coming back into this, and instead of these 3, there'd just be 1. So 51 here, and the internal states are 50. So if you follow that, then 51 times 50 plus, there are 50 biases here. So if you add that and then you multiply by 4 sets here, because there's forget gate, 2 input gates, and an output gate. If you compute that, that comes to 10,400. So that is the magic of how the LSTM is organized. This is in fact a perfect structure to understand how it's internally um, working. So with that, I guess let's just run that quickly. And so we can see how many parameters total. It's quite a lot of parameters, which is why the training is so slow. So I'm going to now fit the generator, 2 epochs, and I'm going to run that. And it's going to take a while. It takes about 5 minutes to go through each epoch. So it'll take about 10 minutes. As you can see, I've started this, and at this point, I think I can pause the video, and we'll come back to it when we are ready. So let's just pause the video here. Okay, so now we have finished our fitting, and so now we're gonna go ahead and do the plot for the loss function. We only had 2 epochs, so we still see just a flat line, but the error has decreased considerably in the 2 epochs. And now we're going to go on to predictions, and we first going to predict the training part, and this might take a while as well. So let's see, let's run the predictions for the training set. And so I'm going to pause again till this finishes. Okay, so the training on the train set, um, we're predicting the training set, so that has finished. And now we're going to do the plots to see how that looks. And so here you go. Because it's a training set, which is exactly what we have trained on, it looks extremely good. The predictions match whatever we were seeing. So now we're going to plug in our test data, and that's the scaled test data. And we're going to reshape it and plug it into the model. And remember, the thing that we're doing is that we take 30 samples of the test data and try to predict the next sample. And that's how we will proceed through that. And I have yet another method here which I've commented out. And in this case, instead of taking the input data, what we can use it is start with the input data, but then start to feed in the predicted data. And so you can predict much further out into the future. We're not going to do that in this episode. What we are going to do is just always follow the input, use 30 samples and predict one, and then take the next 30 of the input and predict the next one, and so on. And then we can plot what we see on these. So let's go ahead and run this, and I may pause again because this may take a while. So I'm going to launch this prediction for the test data now. Okay, so we have now run through the prediction part of the test sequence. Now I just want to spend a moment here on how it's done. So obviously we have used a scaled version of the test data from the beginning, and you have to go through this reshaping process. So the input has to be in this format. The number of features in our case is 1. Length is the number of time steps, which is 30 in our case. And so the format of this stuff that goes into the model is 1 by number of time steps by number of features. So that's the reformatting of the input data that we did here. And then we feed it into this the model, and the prediction comes out. We pick out the output and we stuff it into this array or list, and we keep doing that over and over. Um, and That's how we will get this predictions. And now that we have these predictions, the next thing is to plot these predictions. So let's run that. And so there we have it. You can see that we've gone ahead and predicted, and we've plotted the error, and you can see that the predictions um, look pretty well matched here, and only towards the end we are diverging a little bit, but otherwise the predictions seem to be right on. So um, as you can see that using the LSTM models with just 2 epochs of training, we have been able to um, quite nicely predict this time sequence. And if your objective is to do some predictions, you can do those predictions. If your objective is to monitor the error from your predictions to see where the past is not a good prediction of the future, you can do that as well and measure the errors in your time sequence, which is what I like to do. And so I can see that the error is high here. Now I've shown a threshold here. So if you, since the error is fairly small, what you can do is you can play with this threshold, and I'm going to lower this threshold to, let's say, 50, and run this again. And now you can see that um, some of the data lies above that threshold. So you can see that most of the data here is below this threshold, and only the one in red here. So it just briefly goes into an excursion above 50. So the error is fairly small. So if I set my threshold to 50, only these would be flagged here. Deviations here, but everything else is well within tolerance limit of 50. So that's really it for this episode. And I really wanted to go back and recommend that you read this article, especially the understanding of LSTM, long short-term memory, which helps um, solve the time sequences. The most important thing is, how the parameters are used and how it kind of looks like an ANN, bunch of ANNs and then some gates, four gates that are basically forming the structure of an LSTM cell. When you put the hidden units, this is where the hidden units lie. So you can see that this has 2 hidden units. So those two hidden units lie in every single of these gates, the forget gate, two input gates, and output gate. And so that's it. That's all it takes. So hopefully you guys liked this episode, and um, you can run your own sequences. I'll put this code on Bitbucket, and you can run this code. You can apply your own time series and see how your series performs and how well this is able to predict. And obviously, the next thing would be if your sequence does not get predicted well, try to play with this model here and make sure you're applying the model with some tuning to get maybe more elements or the number of features you're using and the number of time steps you're using. Uh, you can try to vary all those parameters and see if you are able to make good predictions of your sequence. So that's it for this episode, guys. And if you like this machine learning series and what you're seeing so far, then do hit like or leave me some comments and subscribe to my channel. And then I can bring you more in this machine learning series. Thanks a lot again, and see you in another episode. Until then, bye bye.